really also, you probably heard that we were touching on, the points of breaking down silos, both in terms of the, departments, but also across like technologies and processes, that kind of thing. And one of the things that we're finding is, the we could say supremacy of like the Chinese and new entrants who have this already baked in from the beginning. So I mean, what design or engineering choices in your experience most influence manufacturability and cost in EV platforms, and how early do you think they should be considered from what you've seen?
Yep. So I think it's better to think about the manufacturability, start from the beginning. Like, what are the requirements for particular stations? How many modules, let's say for an example, if you're just talking about the battery packs, need to come out from particular station? And if are we gonna have first in, first output a kind of approach, as let's say the battery cells goes in from one side of the station and then the other side comes out. And at that point, we need to also keep first pass yield and overall equipment efficiency in mind, because when we have the lowest first pass yield, which means parts need to get rejected
Mhm.
of every now and then. Let's say if the variance mismatched for whatever reason is the testing occurred at particular station. And even though, let's say, if we have really cool software
Mhm.
working, but which is not compliant with the hardware, um, that particular cycle basically need to uh, think. Engineers need to think through about those steps when they are basically laying out the design. Like, we have so many tools like virtual commissioning, or also just designing all the mechanical components in the CAD. So hardware basically lies sitting ideal as compared to software, which evolves over the period of time. So if I have to give one example from the EV sector, like for example, how we would put various cells in entire pack. So pack a Tesla Model 3 or Y usually have about 25 to 300 battery cell, sorry, 2500 to 3000 battery cells. So are we gonna have small modules side by side that can be assembled in a pack, as compared to just have a half of the pack with the positive side of the cells stacked up, let's say on the right, and then the other side on the left. So if engineers do not think through about this, and if they have to frequently retrofit or revamp the station down the line because the equipments are not being able to adapt, as they need to also keep up with the first pass yield and OEEs, it becomes challenging. So yeah, when they come up with the architecture, software as well as hardware, these are the good points to like cover and think through about, even at the beginning stage, at the pilot level. I mean,
Yeah,
Yeah.
and go on, Nick, please.
No, I was going to say it's an interesting one because I suppose there was a point, and still is a point to some extent, where building these things is relatively new. So the process and the thought process in how you lay the lines out, where you arrange. You said like even simple things like whereabouts, a certain part is, where the cells are, where they come in, the direction they're coming in, not mixing cells, and obviously the quality issue as well. All these kind of things have to, sort of considerations. And I kind of just wanted to ask you about that, because one of the things that we know is a challenge is persistent quality issues with EV components. And some of
Mhm.
it is down to the fact that like cells can be quite difficult to test. There are tests, obviously, but the longevity and things like that can be difficult. So what challenges what do you see as like persistent issues around that kind of thing in terms of that battery pack, and how do you kind of trace, or what's the best process for eliminating those kind of root causes within a factory context?
right. Yeah. So when battery cells need to get spliced together to make, let's say, one module, the way we set it, if they're not perfectly aligned, it basically could rattle or make squeaking sound once, let's say, the modules are laid side by side to make a pack. And this basically not only cause the issue of like having them fitted properly on the back, but also electromagnetic noise, because there are metal surface or the enclosure around the battery modules, as well as the ground fault. If let's say the some of the bonds that we need to create with the chassis that's just holding the positive charge as well as the negative charge on the each end of the bus tabs and battery management board that are usually kept on individual module, just so they can output and the current and then feed to the drive unit. So all of these are just the nitty-gritty details about like things that needs to be perfect at the end when the battery modules are and the packs are manufactured. So the way to basically have lesser issues down the line is having the unique ID associated with battery cells, so you know which variants they have, what kind of battery chemistries they have had. So if there is any leak test down the line, that's something you can trace it back and fix all of those issues. When it comes to alignment, as I said, it could make rattling sounds, and so even though now we in the world of AI we talk about having more robots which can inspect things at the end once, let's say, the modules are assembled. Manual intervention, in my opinion, is still important. Yes, robots could be used to pick and place heavy battery cells in an enclosure, but let's say there is a sealant which was not decent amount in particular corner of the enclosure that could something could only be um, checked by, let's say, an operator who was standing there, as well as having the predefined process parameters for all the screws, the set screws that goes on to enclose the battery pack itself, that could reduce squeaking or moving any of the battery cells down the line. So coming up with this kind of parameters basically reduces the quality issues on battery packs.
I mean, that's a whole world of potential challenges I wasn't aware of, really. That's why I like battery packs. I think they're just it's a whole new world of quality issues that perhaps have not been dealt with before. So, Riddy, thank you so very much for your time and input and giving us our great EV section.
Very interesting stuff.
Yeah, pleasure to talk with you again. And hopefully we'll catch up with you again. So thank you, Riddy, for your input on that.
Thank you.
Thank you.
Thank you.
So we are coming to the end of our discussion.
Yes, we are.
But what would we end on? AI.
Yeah.
AI.
How to approach
AI. We've left this one to last because it's still very much an evolving technology. And I think it's something we're seeing which is really exciting and but actually fits in really well with what we've been talking about throughout the event.
Yeah.
But just I mean, if I may, just a couple of things that we'd picked up on.
Please.
I mean, one of the interesting development sides is we spoke to, I think, again, BMW. Automotive manufacturers are building their own kind of chat GPT, to give it a term, within. So it's a closed loop one using their own data, no external data, no data contamination. That's built from data they can assure. So I know BMW have been working with this, and again, and you mentioned earlier on, this democratization means that all this data is accessible to all members of the teams, and there's no fear of outside information with it. But something else that's kind of come is that AI models are only as good as the data that you put into them.
Indeed, yeah.
And that can be tricky because, as you mentioned before, we've had all these data lakes. So how has that been filtered? How has that been sifted? Is any information coming from external sources and things like that? So it's lots of things for car makers and tier suppliers to sort of grapple with. But they do seem to be doing that, getting a handle on it and appreciating that. And it's very interesting to see how this evolves. I remember when AI was spoken about 2 or 3 years ago, and we spoke to some OEMs and they said, no, we're not, we're not going to get into it. Now they're much more readily embracing it. But one thing I've always found with car makers, tier suppliers, anyone involved in manufacturing is, regardless of how shiny it sounds and great it sounds in a press release or something like that, they're very pragmatic in their approach to it.
Yeah, they have to be.
Absolutely,
Yep.
yeah. But to the point of extreme caution. So just a few things there, like the importance of this data. One size doesn't sort of fit all. And also, when we were at the event early this year, we had Fraunhofer discussing things about this, about AI. They said that they had a statistic that over 80% of AI projects fail.
Yeah.
I don't know if that was just across automotive or across wider, but whatever, that's a pretty daunting, specification. It's a statistic. And again, human-centric being part of this. So I'll hand over to you a little bit, I think, on that side of it.
I mean, the AI Quanic agent is being piloted at the BMW purchasing supplier network division.
Yeah.
Which they touched on in Lancet. And this is a customized kind of multi-agent AI system used to aggregate and analyze and prepare relevant data to make complex procurement processes more efficient, essentially acting as an intelligent co-pilot for buyers and strategists. But this, of course, has clear consequences for production as well. I mean, one thing we're seeing is that the future of AI in production it's not a kind of single task robot approach, but rather it's interconnected autonomous agents that handle enterprise complexity. These multi-agent systems allow the OEM to shift AI from a tool for operators to a strategic asset for decision makers to optimize the entire value chain. And not just on the assembly line, but of course for us it has clear, direct and pragmatic applications on the assembly line. I mean, I see AI from across the entire year. One thing we've seen is that next year is definitely going to be converging closely with more automation. We're going to see predictive maintenance definitely absorbing much more of that. And again, it's going to be about trying to sift through these kind of, drying up data lakes to get to, the important pearls at the bottom. So it's about using the correct information, data, which is information, of course, to solve the correct challenges. And that's what we're seeing more and more. And that's definitely something that's going to be growing in 26.
Absolutely. And that data is just getting better. I think now they're learning what these, and far from being